Today, I'll dive into this small, under $5 multifunction sensor. I'll cover the specs, pinout, and wiring, and then show how the various functions can be used in your Arduino code or with ESPHome for integration into your own home assistant. Hi, and welcome to Resin Chem Tech. I'm currently working on a larger, unique project that I hope to share with everyone when it's done. But in the process of these larger projects, I often do research and I run across components I've never used before. And that is the case here. Among some of the features I want for my larger project, it includes ambient light sensing, proximity sensing, and either capacitance touch or gesture control. During my research, I ran across this little quarter-sized device that costs less than $5. What's more, I'll be able to get all the features that I just mentioned via 3 GPIO pins on my ESP32. Now naturally I need to bench test this device since it has so many potential uses. I thought I would go ahead and shoot a separate video just covering this device. As always, be sure to check the video description down below for links to any products that I show or use, along with additional information such as a written guide to this particular video. This is the APDS-9960 and it has the following features. It has proximity detection. It can detect when an object is within a certain range of the sensor. Has gesture or motion detection, including the ability to determine whether an object is moving up, down, left, right, or near, which means something is approaching the sensor, or far, which means it's moving away. It can also detect RGB and ambient light. It means it has individual sensing of red, green, blue, and clear or ambient light levels. Let me clarify a few things when it comes to proximity and gesture detection. This isn't really a distance measuring device like an HCSR04 or something like a VL53LOX. First of all, the range on this is only about 10 to 20 centimeters or 4 to 8 inches. Next, the proximity value that's returned via I2C isn't really a true distance like millimeters or inches that you would get off these other sensors. Instead, it's a range from 0 to 255, and it increases as an object nears the sensor. So the closer an object gets to the sensor, the higher the proximity value. So if you need to determine a true distance, there are better sensors for doing that. In terms of motion or gesture detection, it really isn't a motion or presence detector either. Again, it has a very short range of only around 10 to 20 centimeters. I should mention though that the sensor does use infrared, so much like a PIR motion sensor, it can only detect heat generating objects, and its accuracy and sensitivity can be impacted by temperature, as the ambient temperature nears body temperature, so it probably isn't a good device for a hot attic or a garage either. So while there are better options for individual features, this should work fine for nearby proximity, relative motion, and general light levels all in one small device that only requires 3 GPIO pins, if it works as advertised. Now these features are exactly what I need for my bigger project. Let's take a look at some of the specs and the pinouts. Now this device does have an operating voltage range of 2.4 to 3.6 volts, so we can connect to the 3.3 volts and grounds from our ESP to the VCC and ground pins here. It is an I2C device, so we'll need 2 GPIO pins, one for data and one for clock for our I2C. And this does have a default I2C address of hex 39 that cannot be changed, at least from nothing that I found, so it is a fixed address, which means we cannot run multiple versions of this on the same I2C bus. The INT or the interrupt pin is an interrupt based on proximity. When proximity is detected, this pin will go low in addition to getting a proximity value over I2C. And the final pin is this VL pin, and this can be used to provide a separate 3.3 volt power to the IR sensor that's used for gesture and motion detection. Now you might want to do that because this can draw a little bit more power and it can introduce noise if we power the rest of the board and the IR sensor from the same 3.3 volt line. However, to do that, there are a couple of jumpers here on the board as well. This one over here on this side, which is labeled PS, is a little hard to see. That really stands for power supply, and if we want to use the IR sensor off of the same 3.3 volts that we're using to power the board, we need to close this jumper or place a little bit of solder across the top. I'm going to go ahead and leave it open, and I'm going to supply a separate 3.3 volt line to the VL pin here. There is a set of jumpers over here on the other side of the board, and these are labeled I2C PU, which is the I2C pull-up. If we put a solder bridge across here, we will enable the 10K pull-up resistors for the I2C line. I don't think we're going to need that, but we'll find out during bench testing. I could not find a published field of view for the sensors on here as far as what kind of angle or how wide it detects. At least for my particular purpose, what I'm really looking for is proximity and motion directly in front of the sensor. So I'm not real worried about motion over here on the sides or way above or way below the sensor. We'll take a look at that during the bench testing. And speaking of that, let's go ahead and wire this up to an ESP32 and do a little testing. Okay, I've wired up the APDS-9960 to a standard ESP32 according to the pinout I just described. I'm using the standard I2C pins of GPIO 21 and 22 for data and clock. I selected GPIO 4 for my interrupt pin, and I'm also feeding 3.3 volts and ground to the VCC and ground on the APDS-9960. Note that since my jumper over here is open for the PS or the power supply, I also need to run 3.3 volts to the VL pin, which is going to power the IR sensor. For the initial testing, I'm going to run some simple Arduino examples. Now I'm using the Adafruit APDS-9960 library. There are numerous other libraries, but I found the Adafruit version to be the most reliable with the features I want for my bigger project. Now do note I had to make a small tweak to the library itself because this board is a clone and has a different chip ID from the original Adafruit version. Adafruit version is also more expensive and at the current time isn't available on Amazon. Plus it has those JST connectors that I don't need and may prevent me from mounting the component flush with the surface, which is what I have planned for my project. So I am using a cloned board. The library modification is a simple tweak and I cover how to get the chip ID and update the library in the related blog article if you want the full details. Okay, for this initial test, I'm just going to test the proximity sensor, so that's the only thing I have in my code. Now recall that the proximity sensor is kind of opposite of what you would expect. The farthest away value will be 0 and the closest value will be 255. So it's a little bit different. You can see right now I'm just getting 1s and 2s output on there. So I bring my hand over here closer. We can already see how that proximity number is now going up as I get closer and closer to the sensor until I get all the way up to what should be 255. There it is. And as I move farther away, the number decreases until it goes back to that 1 or 2 value. So the proximity sensor is working fine, but again, as you can see here, it's not really a distance sensor, but it is going to indicate when something comes into proximity by looking at that number that goes up and down, and we can use that in our code. Okay, for this next test, I'm using proximity again, but this time I'm also using this interrupt pin. When I set up this interrupt pin, I can give it a range, and if the proximity value falls within that range, it will pull this pin low, which we can detect as a true-false value in our code. So right now you see it's not detecting any kind of proximity with the thing. I've got the range set here. So again, if I move my hand in, you'll see that all of a sudden now once I fall within that range, and I'm going ahead and putting out the value here just for testing, but proximity has been detected. When I move away again, it goes back to clear. Also, even though I've got presence detected here, again, if it moves out of range, notice it goes back to clear. So I can have a very narrow range or a broad range in terms of being able to detect proximity by using the interrupt pin as well. Next, I want to test gesture detection. Now, gesture detection does use the proximity sensor, so obviously something needs to be in range of the proximity sensor. And if desired, I could also use the interrupt pin here and restrict the range of that proximity. But it should detect as something moves across the sensor and indicate a direction. So if I move across the sensor this way, you'll see that I get an up reading. If I move across the opposite direction, I get down. I have to bump it here. If I move across this direction, I get right, and the opposite direction, back to the left. So it is able to detect left, right, up, and down. Now note that some libraries also have near and far when something is approaching the sensor and something is moving away from the sensor. This particular library doesn't provide that feature, but I don't really need that feature. If you do, you need to look at one of those other libraries, and I'll list all the various options again in that written blog article. But at this point, we've got proximity and gesture detection working. And finally, I want to test the RGB and ambient light level detection. As you can see here, I'm running a sample script, and I'm already getting values for red, green, blue, and clear, which is ambient. And just for an example, I'm going to actually take an LED flashlight here and shine this on this. which ought to go up to the max, and you can see that the maximum value here is 4097. So the values go from 0 to 4097, which is really just an analog signal being fed to the ESP. Now let's take a look at the different color detection here. I'm actually just going to use my phone and put a big red square right over the top of this. So right now we can see that red value is sitting at about 12. When I put this over the top, notice that the red value jumps up. Now obviously the other values are altered as well because it is detecting a little bit of green and blue and an overall light value here. So now I will simply switch this to a blue square and put blue over here. And again, now we can see that our blue value has increased as well as the other colors, but notice that green went up, but red pretty much stayed the same. So now let's go back over again and let's try a simple green square. We'll put that over that. And again, we can see that the green significantly jumped up while the red and the blue altered some. And of course, our overall ambient light level went up. So that went up pretty well. I'm going to try to put my hand all the way over this. And you can see I'm almost getting down. There we go. We've got all zeros across the board. Put the light back in again. So the red, green, blue, and ambient light level detection is working as well. So this one little $5 sensor is able to give us proximity, gesture, and RGB plus ambient light levels. And we can adapt those into whatever project code we need on the Arduino side. But what about ESPHome if you're a home assistant user? For ESPHome, I have the exact same device wired in the exact same way as I did for the Arduino test. And I began by creating a new node based on the ESPHome documentation for the APDS-9960. But as you can see, when I actually installed this and looked at the logs, I once again have this invalid ID. Once again, that's probably because I have a cloned version. And as you can see from the code here, ESPHome is looking for a particular chip ID, which doesn't match the one that I have. The ESPHome library is based on the Sparkfun APDS-9960, which obviously has a different chip ID than my clone. So I had a couple of choices. One, I could just order a Sparkfun board. But for some reason, maybe tariffs, I don't know, the Sparkfun on Amazon is outrageously priced. Directly on the Sparkfun site, I could order the board at a more reasonable price, but would have to pay shipping. I went ahead and ordered a couple anyway, but even 3 days later, it still hasn't shipped, and I don't know how long it will take to arrive. It could be a couple of weeks. In the meantime, I started looking for workarounds for ESPHome like I found with the Arduino libraries. My first attempt was to install my own copy of the ESP component library, modify it for my chip ID, and then import it as an external or custom component in ESPHome. But that resulted in a plethora of other errors. Now, I might eventually be able to work out these errors, but my research for doing so, I found this ESPHome merged PR that is slated for release in the next version of ESPHome, which is 2025.7. And it contains a new chip ID that matches my clones. New versions of ESPHome are generally released around mid-month, so again, I'm forced to wait, meaning I'll probably have to push this video release back a week or possibly even 2. So the Sparkfun boards arrived yesterday afternoon, but before I had a chance to do any testing, and by the time I got up this morning, the new version of ESPHome with the fix for the clone board was released. Now luckily this will allow me to test both the Sparkfun board with the current version of ESPHome and then the cloned version of the board with the updated ESPHome. But before we test the boards, let's take a quick look at them side by side. Now both boards have identical pinouts, and as you can see on the back, they both have the same I2C address. We already know that they have different chip IDs, which I verified by running the Arduino script that returns the chip ID. There's also a visible difference in a few components, but otherwise they look very similar. Now do note that the Sparkfun boards come with these jumpers closed, while on the clone board that they were open. So this means that for an apples to apples comparison, I need to either close the jumpers on the clone board or remove the solder and open the jumpers on the Sparkfun board. And since I've done all of my testing so far with those jumpers open, I've went ahead and I've removed the solder and opened up the jumpers on the Sparkfun board. One final thing to note is that the Sparkfun board did not come with these pin headers. So if you're planning on attaching this to a breadboard or connecting with something like DuPont jumpers, you will need to supply your own pin headers for the Sparkfun. So the first thing I'd like to try is actually swapping out this sensor to see if it will resolve the issue that I'm getting with the invalid ID in my current existing version of ESPHome. And luckily, since I went ahead and opened the jumpers on the Sparkfun board and the two boards have the exact same pinout, I'm able to simply swap in the new Sparkfun for the old clone board. Well, let's take a look at the ESP logs and see if that fixed our ID issue. And we have that anymore, and look at that, we're now getting data back. So obviously the Sparkfun board with that chip ID works with the current version of ESPHome, but I'm curious to see if I upgrade ESPHome with that fix, if it will also work with this clone board. I put the original board back. Again, since all the wiring is the same, I just swapped out the Sparkfun with the cloned version. I also updated ESPHome to the latest release, which is 2025.7.0 at the time of this recording, and you can see buried in the release notes is the addition of a new chip ID 0x9E for the APDS-9960, which is the chip ID for my clone board. I flashed the updated version to the ESP32 without changing anything in the YAML configuration. So now let's take a look at the logs for the clone chip and see if our error is gone. And it is. That's fantastic. We now see we're getting data back from the clone chip just like we did with the Sparkfun. So once you're on ESPHome 2025.7, you can use the clone chip without modification. But now let's take a look at the device and entities that get created in Home Assistant. Under integrations here in Home Assistant, you can see that my new ESPHome device was automatically discovered. I just simply need to click Add to add it to Home Assistant. And I can optionally specify an area here. Since this is just a test board for me, I'm going to go ahead and leave the area blank, skip that, and finish. And now we can see the device and all the entities that are created from ESPHome. You can see here in the logs where I've tested the up, down, left, and right binary sensors, and they all seem to be working fine. But there are some differences in how data is reported here versus what you would see in Arduino. For one, note the proximity is listed as a percentage. Now, I actually am showing a little bit of proximity here, but I believe it is actually detecting the overhead camera right above it. But you can actually see as I put my hand here in front of it, how that percentage is actually moving up. And if I move my hand back out of the way, that proximity percentage drops back down. So instead of 0, which is farthest away, all the way to 255 is the closest, which we saw in Arduino. In this case, we get a percentage of how close something actually is to the sensor, which is kind of a nice difference. In a similar manner, our light detection works in much the same way as a percentage. So instead of being something like 0 to 4097 that we saw in Arduino, we're actually seeing a percentage here. Now that percentage does seem a bit low to me, considering the fact that it really maxed everything out on the Arduino. I may have to go back and look at adding some filters to the configuration of ESPHome, but the important part here is it is reporting back the different red, green, blue, and ambient or clear light levels. Now it's all fine to look at things here, but it'll be a lot easier to see this if we take these entities and create a simple example dashboard. Okay, here you can see I've taken all of those ESPHome entities that were integrated into Home Assistant and I've put them here on a simple dashboard. Now I did tweak a few things, so I gotta go ahead and mention that. For one, this library doesn't use the interrupt pin, so I've went ahead and I've disconnected that. The next thing that I've done is the binary sensors for gesture control update from on to off so rapidly. I've created a text sensor here and I'm just tracking the last movement. So the last movement it detected was up. It'll stay that way until I move back across for a different direction. So there is right. I come back across the other way, should be left. And we saw up this direction. Of course, the opposite of that would be to come back down again. That is all working. We've got the RGB and ambient light levels. Once again, if I take a bright flashlight, shine that on there, you see that the percentage jumps up. Now, it's not jumping up a lot. There are gain settings that you can use in ESPHome, and I probably need to go back and tweak those a little bit. I did change them some, but I probably need to boost the gain on the light level sensor. But I'll leave a copy of the ESPHome configuration file that I'm using for this particular dashboard, and I'll put that in a gist file, and you can find a link to that down in the video description. But the good news is everything seems to be working here in Home Assistant. And of course, while you can show these on the dashboard, you can also use all of these entities in your Home Assistant automations and scripts. For example, you might do something like turn a light on by swiping your hand up, turn the light back off by swiping it down, maybe even things like increase the brightness going this direction and decrease the brightness going that direction. So I have found that this one single device can take place of 3 separate components I was planning on using for my project. But do note that in this particular case, some of these cheap clones did cause me issues. And while it might be a little bit too soon to reveal my larger project, I do have some other components that I may detail in their own video, as they're things I've not used before that I do plan on putting into this bigger project. I'm not sure when I'll get that bigger project done, but until that time, I'd like to say thank you for watching, and I hope to see you again soon.